It's winter again, and you get snowstorms in winter.
That massive winter storm making its presence felt. Newport, Rhode Island, like a howling wind tunnel. Wind there gusting at more than 60 miles per hour. Just south of Boston, snow whipping. With states of emergencies declared in 7 states. Many governments and schools closed today as officials prepared for the worst.
Our top story this morning, the big and powerful blizzard affecting over 70 million Americans.
It could be the biggest snowstorm in nearly 100 years.
When we think about climate change and how we actually experience it, it's mainly through the changes in the extremes. It's not through the global mean temperature.
Record-breaking snow. Worcester, over 34 inches. In Auburn, you can barely see the street signs. Hudson, Mass. got 3 feet too, enough to trap residents inside their homes. In Nashua, New Hampshire, firefighters racing to clear buried hydrants. And in Boston, where schools are closed again tomorrow, they're digging out from the biggest January snowfall on record.
We're following yet another storm about to hit just hours after the record-breaking blizzard.
We could see snow measured by the foot.
Across this region, so many opening their doors to sights like this. Snow piled high, breaking in. That's Courtney Berry's door.
Winter knocked and let itself in.
Yeah.
In January 2016, Winter Storm Jonas inundated portions of the Northeast with record-breaking snowfalls that exceeded 3 feet in places. Last year, Buffalo was buried under more than 7 feet of snow in only 2 days, and Boston had its snowiest winter on record. In 2011, this Chicago blizzard dumped so much snow that it buried cars, and in 2010, the Northeast had Snowmageddon. How is it possible to have record-breaking winter storms and blizzards in a warming world?
In order to get snow, you need 2 things. You need 1, a lot of moisture in the atmosphere, and 2, cold enough temperatures to have snow.
With warming, there's more heat, there's higher temperatures, and the atmosphere can hold more water vapor, and the rate is 7% per degree Celsius. In over wet areas where it's ocean, there is more moisture as a consequence of this. There's more snow, however, potentially in midwinter, because the atmosphere can hold more moisture as long as it's cold enough. When it does rain, when it does snow, when it does precipitate, it's apt to produce even more snow than it would have done in the past.
And there is some evidence that the U.S. climate is a little bit colder than optimal to get heavy snowstorms, because your heaviest snowstorms occur right around freezing. That's when you can have the most moisture in the atmosphere to generate snow. So if you've got those temperatures right around freezing, a good supply of moisture from maybe record warm waters in the Atlantic, you can get record sorts of snow.
Data from the National Weather Service shows that vast expanses of water off of North America are up to 7 degrees Celsius above normal. This has greatly amplified moisture in the atmosphere, and Winter Storm Jonas has been able to tap into this moisture and dump it as snow over the Northeast. Warming lakes can also have a dramatic impact on moisture available to storms. This study, published in Geophysical Research Letters, confirms that the world's lakes are warming almost 3 times as fast as the oceans are. The Great Lakes region is particularly vulnerable to heavy snowfall because its lakes are among the fastest warming bodies of water on Earth. When a disturbance in the jet stream allows cold polar air to blow over any of these lakes, storms have more and more moisture to siphon off and dump as snow.
You have this cold air mass that is blowing over the lake. Okay, now what happens is since the lake is warmer, it is actually going to warm that air mass from below. So what does warm air do? It wants to rise up. As it does that, it cools and condenses, blows over the city, and it just starts puking snow.
Blinding lake effect snow squalls and gusting winds pummeled parts of Buffalo, New York, and surrounding areas on Tuesday, dumping more than 5 feet of snow in some spots, falling at rates of up to 5 inches an hour.
The 2014 National Climate Assessment shows the upward trend in the heaviest precipitation events over the last century. The most dramatic increases have been in the Midwest and the Northeast. At the same time, Northern Hemisphere winter storms have become more frequent and intense, and the storm tracks have shifted northward. Aside from changes in the hydrological cycle and shifting storm tracks, extreme snows some years and almost no snow other years might be indicative that other changes in the climatic system are affecting snowfalls.
This difference in temperature between high latitudes and low latitudes is what drives the jet stream.
If you remove a whole bunch of Arctic sea ice, you add all the extra heat. If there's less temperature difference between the equator and the pole, that means that the jet stream is going to weaken some.
If that temperature difference is strong, then the jet stream is strong. As this gets weakened with the enhanced warming in the Arctic, the temperature difference has also weakened, which weakens the jet stream. When the jet stream is weaker, it tends to take a much wavier path. These waves tend to get larger in the north-south direction.
The jet stream tends to get stuck. It gets locked in place in what's called a blocking pattern.
Once the jet stream gets into one of these very wavy patterns, it's very slow to shift. Many types of extreme weather are related to weather patterns that get stuck, if you will. So think of a drought, for example, happens when you have dry weather for a very long time. Heat waves. I mean, if you have one hot day, it's not news, but if you have a whole string of them, like we had in Texas this summer, that becomes big news. Or if you have snowstorm after snowstorm, like we had last winter and the winter before along the East Coast, that's also big news. So what we're finding is this tendency for these waves to move more slowly in the jet stream is increasing the probability for the types of extreme weather that are related to slow-moving weather conditions or weather patterns that seem to be stuck.
Although there's some debate about how global warming is affecting the jet stream, the Earth's climate is changing and the Earth is warming up. As the world warms, it's still possible to have a few cold records, but the warm records become much more likely and the cold records become much less likely.
And in the 80s, it was edging up more to more warm records. In the 90s, it was about 1.4 to 1. And by the 2000s, it was about 2 to 1. And then if we look at more recent times, if we look at 2010, it's about 2.3 to 1, 2011, 2.7 to 1. And for the first 6 months or so of this year, it was running at a ratio of 9 to 1. So this is where there's clear evidence of climate change. We're breaking records on the high side. This is not something that would occur in an unchanging climate.
A lot of people jump to the conclusion that because it's warming, we shouldn't have snow anymore. But that's a gross misrepresentation and oversimplification of the science.
We expect to see heavy snowstorms going forward in the future, and it's possible, although the research isn't clear on this, that you could get even more heavy snows if you've got stronger storms with more lift, able to take this moisture, lift it up high where it can cool and snow down to the surface. I wouldn't expect snowstorms to quit in the future, even 50 years from now. We'll still get heavy snowfalls. They'll just be more limited during the time of year they can fall. Winter will start later, it will end earlier, but you'll still get heavy snowstorms.
So far this entire season until this storm, New York City had only gotten a trace amount of snow. Now in less than 24 hours, the city has gotten an entire winter's worth.